All right. Okay, so this lecture is going to be the beginning of our primate unit. So we're going to go over primate classification first, and then we'll go over locomotion and then eventually behavior next week. So primate classification is all about the details. So there's gonna be lots of new terminology that we're learning this week. So make sure you're making your flashcards, make sure that you're getting comfortable with what these terms mean, because it will help you identify and classify the groups of primates. So this goes along with chapter 5 in your explorations textbook. All right, so the beginning of the chapter, we'll talk about what exactly is a primate. So what defines a primate order, essentially? What separates us from the other mammals? So the big three are the arboreal adaptation, sorry, the tongue twister, arboreal adaptation, dietary plasticity, and also parental investment. So arboreal adaptation is the suite of physical characteristics that enable primates to live in trees. So primates will have various forms of locomotion. Some primates will use their arms mainly to swing from branch to branch. Some primates will walk on all fours on limbs. Some primates will vertically cling and leap. Some primates will be knuckle walkers, and some primates will be bipeds. That would be us. So we have a variety of different forms of locomotion, but we do have adaptations that allow us to be arboreal. So those that are arboreal, the brachiators tend to have really powerful pectoral girdles, their shoulder muscles, and they tend to have longer arms. They tend to have longer finger bones. Dietary plasticity is basically a fancy way of saying diversity in diet. And like I always say in the game of evolution, diversity always wins. So for primates, that's one thing that makes us so adaptable, is we do have a very diverse diet. Now, of course, just like any other species, primates will sometimes focus in on certain food sources. Some primates will focus in on mainly foliage. Some primates will focus in mainly on fruit. Some will focus on insects. Some will eat a variety of all of those things. But in general, primates have dietary plasticity. They have the capability to switch food resources if one is no longer available or not available during a certain season. Primates also tend to have a high degree or high level of what we call parental investment. So our offspring are born very dependent upon us for survival. Especially when we're looking at humans, our pelvis is more narrow to allow for bipedalism, but we have very large brains. So our brain size is somewhat limited in utero, so essentially during that prenatal stage, because if the brain size gets too large in utero, then the baby won't be able to safely pass through the birth canal. But we do have high levels of parental investment, so our offspring are born very dependent upon mom and dad for survival, and they tend to be dependent upon mom and dad for survival for at least 10 years. Obviously, humans much longer. All right, so primates, as far as our senses go, we have the highest reliance upon both vision and touch. So you can imagine it kind of goes along with our arboreal adaptation. If you're leaping from branch to branch, you really want to be certain where that next branch is. So primates also have good depth perception. They have stereoscopic vision that makes them able to really successfully live in the trees. So in addition to that, they have enhanced sense of touch. So the end of our fingers and toes are sensitive and allow for maximum information from the environment. So our fingers are covered in these ridges called fingerprints, and those ridges, when you put your fingers together like this, that friction is what is actually giving you an enhanced sense of touch, essentially. So these ridges enhance tactile senses. They increase the amount of friction and provide resistance to slipping. So that's advantageous for holding onto branches while swinging through trees, and later on making and using tool technology. All right, so some more on the arboreal adaptation. So we have a reduced reliance on the sense of smell. So the only exception is going to be some of the lower order prosimians will retain a wet nose called the rhinarium. So that's exactly like the nose that your dog or cat might have at home. That wet rhinarium is indicating that that species has an increased reliance upon smell. So really just the lower order prosimians, those are the only ones that have this reliance upon smell, at least as far as the primates go. Smell is going to be a secondary sense, or one that we don't rely directly upon for most primates. All right, so dietary plasticity. So this is just giving you kind of a visual here of the wide variety of food items that primates will consume. So primates will sometimes focus in on just vegetation. We call those folivivores. So that's foliage eating. They may focus in just on fruit. We call those frugivores. They may focus mainly on insects. We call those insectivores. And then those that eat everything are called omnivores. So for omnivores, it's really just humans and chimpanzees because not a whole lot of primates consume meat. It's actually pretty rare to eat meat in the primate order. We don't really see that happening until later on in our human evolutionary past. So we see the inclusion of more meat in the diet about 2 million years ago with the emergence of Homo erectus. But as far as our living relatives, we see chimpanzees will consume meat and hunt for meat. But it's more of an opportunistic, occasional thing. They're not consuming meat daily and possibly not even weekly. They may have meat a few times a month, essentially. Primates, when we get into the different infraorders, we'll talk about their dental specializations. So primates have evolved to have different dental specializations. So when you're looking at the teeth in the front of the mouth, those are called incisors, and then the teeth in the back of the mouth, those are called the premolars and the molars. So if you're looking at diet, the premolars and the molars are going to be more useful in reconstructing what that primate might have ate. So if you're looking at the molars and you see that they have these bilophodont ridges like that, that's something that you see only in the old world monkeys. And the old world monkeys are going to be mainly folivivores. They're consuming mainly foliage. Lesser apes, greater apes, and humans have a Y5 pattern to our molar patterns, or to our molar cusps, we should say. So that means you can draw a Y in the valley in between those molar cusps. So that's going to be what we see in the lesser apes, the greater apes, and in humans. All right, primates have a high degree of parental investment. So female primates give birth to fewer offspring than other mammals. The amount of time that they invest in the survival of each offspring is high. Development periods are longer, especially for the great apes and for humans. So you're seeing that it's advantageous for primates to space out their births at least 3 to 4 years. Because our infants are born so dependent upon us for survival, it's not advantageous to try to have a child every year or even every 2 years. Because those primate babies are practicing on-demand breastfeeding, oftentimes for several years. So really, it's not advantageous to try to have another child until that on-demand breastfeeding has stopped. All right, it's just more on parental investment. All right, so more on the anatomical features that allow for arborealism. The clavicle, that's the collarbone, acts as a strut to keep the upper limbs to the sides of the body. The ulna and the radius, those are the two bones in our lower arm. So the bone that connects on the thumb side, that's the radius, so that allows us to pronate our hands like this. And then the bone that's on this side here is actually the ulna. So when you hear that phrase hitting your funny bone, when you hit that tip of your elbow on a table or something, what you're actually hitting is the tip of the ulna, not the humerus. The phalanges, those are the finger bones and the toe bones. The phalanges, especially in the brachiators, are going to be really long and curved. And that's allowing for them to wrap their hands around branches. Most primates, the vast majority of primates, have an opposable thumb. So that just means that that thumb can then touch all of the other fingers. So you can grip things with your hands. So that's obviously allowing for arboreal swinging and also later on allowing for the use and production of tool technology. Primates also have a powerful precision grip. And primates have a distinctive spinal column with 5 different vertebrae types. And I'll show you a picture of that here in just a moment. So we have a clavicle that acts as a strut to keep the limbs to the sides of the body. We have an ulna and a radius that allow us to rotate our forearm. Our phalanges, our finger bones, and our toe bones allow for both hand and foot dexterity. We have opposable thumbs, and most primates also have an opposable big toe that allows digits to touch other fingers and also for gripping. We have a powerful precision grip, and we have 5 distinctive vertebral types. All right, so in general, primates have a flexible, generalized limb structure that allows for various forms of locomotion. So when you hear that term ancestral, so ancestral always refers to a trait that's older. So think ancestral older and think derived newer. Okay, so flexible limb structure that allows for various forms of locomotion. So we're going to talk about the forms of locomotion probably on Wednesday, but just now know there's going to be 5 or 6 different types of locomotion that we'll talk about that will be different in each primate. We have prehensile or grasping hands and feet. We have a retention of 5 digits on the hands and the feet. That's an ancestral trait. We have an opposable thumb and big toe. That's a derived trait. So derived traits are ones that are just they're more recently developed in our evolutionary past. So think ancestral, older traits, deeper in our evolutionary past, and then derived traits are newer, more recently diverged traits. The vast majority of primates are going to have nails instead of claws on all of their digits. So that's a derived trait. So the only exception is going to be some of the lower order strepsirrhines. Some of them have a combination of nails and claws, but all the higher order primates will have nails instead of claws on all of their digits, all of their fingertips and toe tips. They will have tactile pads that are enriched with sensory fibers at the ends of those digits, and that's a derived trait. Primates, the vast majority of the order, the vast majority of the order are what we call diurnal. So diurnal just means that they're active during the daytime. The only exception, again, some of the lower order strepsirrhines are nocturnal, and then the tarsiers are also nocturnal. But the vast majority of the primate order is diurnal. Primates also have color vision. They have depth perception. They have stereoscopic vision. So that's the ability to perceive objects in 3 dimensions. They have an expanded neocortex. So the neocortex, that's the portion of the brain where information from the different senses is combined and processed. So in the frontal region of our brain, we're taking in all that information that we get from vision, from smell, from touch, from hearing. We're taking in all of that information and processing it in the neocortex. And as primates, we also have expansions of the regions that are related to both motor and sensory functions. And those traits are developing together during the postnatal stage, or those capacities are developing together during the postnatal. So primates also have prolonged gestation. So gestation is the period of time from conception through birth. So that's the prenatal stage. We have a reduced number of offspring. So we're what we call case-selected animals, not R-selected. So we tend to have fewer births and we tend to space them out over several years. We don't have litters like mice or bunnies do. We tend to have single births and we tend to space them out over several years. We have greater dependence upon flexible learned behavior. So that's part of our social organization and our tendency to live in social groups and depend upon each other for survival. We have a tendency to live in social groups. And sorry, that's a repeat there. We have a tendency towards diurnal activity patterns. So that just means active during the day. So we have prolonged gestation. So that's a prolonged prenatal period. We have fewer number of offspring. That's a derived trait. We have delayed maturation. So that's essentially childhood. We have greater dependence on flexible learned behaviors. We tend to live in social groups. And we have a tendency towards diurnal activity patterns. All right, this slide here is just showing you the opposable hallux. So the hallux is the big toe. So you've got the human foot on the right-hand side and then a chimpanzee foot on the left side. So you see in the chimpanzee, the hallux is slightly diverged. It's opposable, which is allowing the foot to grip. There it is in real life. Well, with the skin on there, I should say. And then these are the 5 vertebral types that I was talking about. So in primates, we have 5 different types of vertebrae. And we have an S, as humans, we have an S curvature to our spinal column to allow for bipedalism. So the vertebrae that are in our neck, those are called cervical vertebrae. So the way I remember it, if you've got a cervical collar on, that's a collar that goes around your neck. The ones in green, those are called the thoracic vertebrae. The ones in our lower back, those are called lumbar vertebrae. And the way I remember that, if you're furniture shopping or car shopping, they always tell you about the lumbar support in the seat or in the piece of furniture that you're buying. So that's how I remember the lumbar is the lower back. So there's 5 lumbar vertebrae. And then at the bottom, we've got the sacrum and the coccyx. So as humans, of course, we have lost the external tail, but we still have the remnants of the tailbone here at the very bottom. But the sacrum, those are all fused vertebrae, at least in humans. And then at the very bottom down here, we've got the coccyx. So in most primates, you're going to see this, what we call C curvature to the spinal column. And then in modern humans, we're going to see this S-shaped curvature, which we'll learn later is an adaptation to bipedalism. All right, questions so far? Okay, so now we're going to get into even more details. So we talked about exactly what is a primate, how do we define a primate? So now we're going to divide it up even further and look at the different groups of primates. So we're going to have the lower order, what we call strepsirrhines or prosimians. So that's going to include the tree shrews, the lemurs, the lorises, and the tarsiers. And then we've got the higher order primates, which are called the haplorhines. So the haplorhines are going to be further divided into the platyrrhines and the catarrhines. The platyrrhines are the New World monkeys. And then the catarrhines will include Old World monkeys, apes, and humans. So we see that the prosimians, they are confined to Central America, or I'm sorry, it's not Central America, Central Africa. We've got the tree shrew in Central Africa. We've got the lemur in Madagascar. And then we've got lorises and tarsiers in Southeast Asia. And then the New World monkeys are found only in the New World. So the New World is the Americas, the Old World is Africa and Asia. So New World monkeys, because we don't have any naturally occurring primates other than humans in North America, we see all of the New World monkeys in South America. And we'll talk about some species of New World monkeys here in a moment. And then the Old World monkeys. So Old World monkeys are found in the Old World. The baboons and macaques are found in Africa. Colobus monkeys and langurs are found in Africa and also in Southeast Asia. And then the guanins and mangabeys are also found in Asia. And then the apes. So we've got the lesser apes and the greater apes. The lesser apes include the gibbons and the siamangs. And then the greater apes include orangutans, chimpanzees, bonobos, and gorillas. So we find chimpanzees, bonobos, and gorillas in Central Africa. And we find orangutans and gibbons in Southeast Asia. All right. Cute primates there. Okay, so let's talk about the details here. So we've got 2 primate suborders. So envision, and I recommend drawing it out on a piece of paper. So you've got, at the very top, you've got the strepsirrhines and the haplorhines. So strepsirrhines are considered lower order primates. And then haplorhines are considered to be higher order primates. Let me see if I can draw it out for you guys here. But my advice is take a piece of paper and turn it so it's horizontal. And you're going to draw out this primate classification chart here. So it's going to look something like this. So on your piece of, oh, you can't really see it here. Oh, kind of. I was like, at the top, you got your strepsirrhines and your haplorhines. And then we're going to put the characteristics underneath. So the strepsirrhines, the lower order primates, are also called prosimians. And I don't know why they have to be confusing about it, but I will tell you why they have 2 different classification schemes. But just know that in this class, we will use strepsirrhines to refer to the lower order primates. So strepsirrhines include lemurs, lorises, galagos, and patos. The strepsirrhines have a relatively smaller brain size. They do not have full postorbital closure. So postorbital closure is the bony material that's covering the eye sockets. So all of the higher order primates will have bony material that's completely protecting the orbits. The only exception is those lower order strepsirrhines. They will have what's called a postorbital bar, but they do not have full postorbital closure. So I'll show you what a postorbital bar looks like here in just a second. The lower order strepsirrhines also have a slight lateral orientation to their orbits. So lateral means to the side, anterior means forward facing. So the strepsirrhines have a slight lateral orientation to their eyes. They have the retention of the moist rhinarium, that's the wet nose. They have a feature called the tooth comb, so that's in the lower jaw and the mandible. The incisors, the front teeth, are going to jut straight forward. And that's actually a grooming adaptation. I'll show you guys a picture of that here in a moment. And the lower order strepsirrhines also have a grooming claw. And then the higher order haplorhines, the haplorhines will have a relatively larger brain size. They do, in fact, have full postorbital closure, so they have bony material that's completely protecting their eye sockets. They have anterior or forward-facing orbits. They have a completely fused mandible. They have a shorter snout, and they have lost the wet rhinarium, so they're dry-nosed primates. And they have nails instead of claws on all digits. You guys have questions so far? All right, so let's talk about the prosimians, the strepsirrhines, in a little bit more detail. So these ones, these are the smallest of the primates typically. Well, tarsiers are pretty small too, but these ones typically overall, this group includes the smallest primates. These are the oldest living primates, so they go the deepest back in our evolutionary history. They're the first primates, essentially the first modern primates that are still alive today. They have a developed sense of smell. So that's, remember, the one exception, most primates have enhanced vision and touch. The prosimians are the only exception. They have an enlarged olfactory bulb and scent gland. Those are regions of the brain that are related to smelling. They have a combination of nails and claws on their digits. And because of that, they tend to have less dexterity. So they're not quite as great at being arboreal. They do a kind of locomotion called vertical clinging and leaping, which I'll show you a video clip of here just in a second, because it's a really cool way of locomotion. Geographically speaking, we find lemurs only in Madagascar, and then we find the galagos and patos, we find those in Southeast Asia. So let me show you a little video clip about the vertical clinging and leaping, because it's pretty cool. So this is a specialized form of locomotion that we see predominantly, well, actually only in the strepsirrhines. Let's pull it up here in our module. Okay, locomotion. All right, so vertical clinging and leaping. So the body is going to be oriented vertically, and movement is going to occur by leaping from tree to tree. These primates tend to be hind limb dominant, so that means that their femur and their tibia are longer in comparison to their humerus and the radius. They tend to push off with their legs and then leap through the air, and they land in another tree in an upright clinging position. This is practiced in some lemurs, lorises, and tarsiers. And the tarsiers also have an unusual tibia and fibula bone. So the tibia, that's the shin bone, and then the fibula, that's the long skinny bone that's lateral to the side of the tibia. So let's watch this clip because it's a pretty interesting, cool form of locomotion. So this is what we see only in the lower order strepsirrhines. Let me make sure I optimize for sound clips here. And then I will show you this clip. All right.
Deccan's Shifaka. This youngster is 3 months old and already practicing the vital skill of leaping. No one cluster of trees is large enough to sustain a whole family of hungry Shifakas. This mother and son need to seek out another pocket of vegetation, possibly hundreds of meters away. They must run a deadly gauntlet. These limestone shards stand more than 100 meters tall and are sharp enough to shred human skin. But Shifakas have thick, rubbery footpads and spring-like legs that can leap 9 meters in a single bound. These lemurs have evolved into blade runners. Safely across, mother and son claim their reward. The fresh, juicy leaves they need to survive.
All right, so we call that form of locomotion vertical, clean, and leaping. So we saw Shifakas in that particular video. All right, let's move on to any questions about Strepsirrhines before we move on to the next type of primate. So this is that, so I was telling you guys about the post-orbital bar. So the lower order Strepsirrhines are the only ones that do not have full post-orbital closure. They have a post-orbital bar. So when you're looking into the orbits, you see that you can see there's not bony material completely supporting and covering the eye sockets. They also have an unfused mandible. They tend to have longer snouts. They have the moist rhinarium, that's the wet nose. They have the tooth comb and the grooming claw. All right, so the tarsiers, these are kind of the oddballs out. And this is the reason why there's 2 different classification schemes for the primates. So those that subscribe to the prosimian anthropoid way of classifying, they consider the tarsiers to be part of the lower order prosimians. But the newer order classification scheme, the Strepsirrhines and Haplorhines, which is based on some recent genetic studies, shows that the tarsiiforms are actually much closer to the higher order Haplorhines. Sorry, lots of tongue twisters today. So the tarsiiforms, they're a separate infraorder, but they're going to be underneath the Haplorhines. So they have a similar, and they're interesting little guys and gals because they have a lot of traits that are a kind of a combination of Strepsirrhines and Haplorhines. So they're definitely maybe a transitional form in between the two. And when you look at these little primates, you wouldn't necessarily, when you look at this little creature, you wouldn't necessarily assume it's a primate. It doesn't look super primate-y until you look at it closer when you see the opposable thumbs. They are vertical clingers and leapers, so they use the same form of locomotion that we just saw with the shifakas. They have really large eyes, so orbits are eyes. They have really huge eyes that are adapted for being nocturnal. So they are one of those exceptions we talked about earlier, that most primates are diurnal, but these are one of those exceptions. They also have a trait in the eyes and the orbits called the tapetum lucidum that allows for increased night vision, or exceptional night vision, I should say. They have an unfused mandible, just like you'd see in the Strepsirrhines. They have a grooming claw, like you'd see in the Strepsirrhines. And they have molars with really sharp, pointy cusps. Those are what you see on the molars. So they are mainly insectivores, and they use those really sharp, pointy molars to break up insect exoskeletons. All right, there's another picture of the tarsier. All right, so now we are underneath the haplorhines, and there's going to be essentially 3 divisions under the haplorhines. So there's the tarsiers that we just talked about, and then there's the platyrhines. So the platyrhines are just the New World monkeys. And then the catarrhines will include the Old World monkeys, apes, and us, humans. So I'd recommend drawing it out on a piece of notebook paper. So we're doing lines underneath the haplorhines now. So we've got platyrhines and catarrhines and the tarsiers. So New World monkeys include spider monkeys, squirrel monkeys, capuchins, tamarins, marmosets, howler monkeys, woolly monkeys, salkies, and eucharis. That's not an exhaustive list, but that's some of the big ones there that those of you that are planning on going to the zoo, not this weekend, but next weekend, we'll see spider monkeys, squirrel monkeys, capuchins, howler monkeys, and I believe there's also woolly monkeys at the LA Zoo too. They used to have eucharis, but no more. All right, so some of the characteristics of the platyrhines. So they have what we call side-directed nostrils. So when you're looking at the nostrils, you see that they're kind of oriented and pointing towards the side. They have a dental formula. So when we do dental formula, we're going to start at the front of the mouth. So on each side, we're going to divide the mouth into quadrants. So we're going to count the number of teeth on each side. So the 2 is referring to the number of incisors. The 1 is the canine. The 3 is the number of premolars. And then the other 3 is the number of molars. So New World monkeys have a dental formula called 2-1-3-3. So that means on each side, in each quadrant, there's 2 incisors, 1 canine, 3 premolars, and 3 molars. The platyrhines do not have the bony ear tube. So the bony ear tube, it looks kind of like a little straw leading up to the external auditory medius. That's essentially the ear hole. They do have, not all of them, but most of the New World monkeys have a feature called the prehensile tail. So the word prehensile means grasping ability. So the prehensile tail, and I'll show you a video here in a moment, but the prehensile tail allows them to use their tail as basically a 5th hand. So that's an arboreal adaptation that makes them more effective at locomoting in the trees. And overall, they tend to have lower levels of sexual dimorphism. So that's a trait that is familiar from our human adaptation chapter, but sexual dimorphism, just to review, means differences in overall body size between males and females of the same species. It can also sometimes include differences in secondary sexual characteristics. We'll see in the gorillas that the male gorilla has a really pronounced, prominent sagittal crest, and the female does not. We'll also see in a lot of the Old World monkeys, like gelada baboons are what I'm thinking of right now, that have the males have really prominent, large canines, and the females do not. So overall, sexual dimorphism is just referring to differences in overall body size, but it can also refer to differences in the physical attributes between males and females of the same species. And geographically speaking, we find the platyrhines only in Central and South America, and in zoos, of course. So there's a picture of the prehensile tail there. So you see they're using their tails in their locomotion pattern. And let me show you guys a little video clip of the locomotion pattern here. So the New World monkeys are going to utilize what we call arboreal quadrupedalism. So just like it sounds, so arboreal means tree dwelling, and then quadrupedal means movement on all fours. So some key points on arboreal quadrupeds. So arboreal quadrupedalism is the movement on all fours in the trees. The arboreal quadrupeds will walk and run along the horizontal surfaces and jump from branch to branch. They have prehensile hands and feet. They have long phalanges, finger bones. They have a scapula that's positioned laterally on the rib cage. So the scapula is a shoulder bone. And most have the prehensile tail, platyrhines. All right, so let's watch this locomotion pattern here. These are spider monkeys, and they're going to show you an example of an arboreal quadruped. And take special note at the prehensile tail, how that's working, and take special notice of also how the baby uses the prehensile tail to more effectively hold on to mom as mom's locomoting in the trees.
They don't look like a regular primate that has 4 limbs. They have an additional limb that is their tail, so they really look as like spiders when you look at them in the canopy. Spider monkeys are one of the largest primates in the Americas. They can weigh up to 10 kilos, and they are quite amazing because when you look at them, and probably that's why they get their name, they look like spiders. Prehensile tail is a tail that can be used to grab from any substrate. It is like having an additional hand, literally, only that with a single finger. In fact, they have like a bearskin pad on the underparts of the tail, but it has a very, very detailed precision in order to grab from any kind of substrate. Spider monkeys start using their prehensile tails very early. In fact, after a couple weeks old, baby spider monkeys will start to ride on their mom's back. And it's very interesting that they wrap their tails around their mom's tail, and this is like a seat belt, like a security belt that they have for hanging tight to their mothers. I think prehensile tail is a very unique adaptation because monkeys that have a prehensile tail are able to hang from their tail while they're foraging and then free their hands in order to be more efficient. They can also hang from their tails while wrestling and playing with other members of the group, but especially when they're moving along or across the canopy, they're able to secure themselves while jumping from one tree to another. So it's an additional security for them, especially being large-bodied primates that live 30 to 50 meters above the ground.
All right, so that video showed you the predominant form of locomotion for the New World monkeys, the platyrhines. So we call that arboreal quadrupedalism. All right, what questions do you guys have about the New World monkeys? Okay, let's do one more group, and then we're going to go into our breakout rooms a little bit earlier today because I want to give you guys time to get to know your new group mates, and also, of course, give you time to work on your notes as well. But let's talk about one more group. We'll talk about the Old World monkeys before we go into breakout rooms. So the infraorder Catarrhine. So you're looking under haplorhines, and I recommend drawing this out on a sheet of paper. So underneath the haplorhines, We already talked about the tarsiers, the tarsiiforms. We talked about the platyrrhines and New World monkeys. And now we're going to talk about the catarrhines. So the catarrhines will include Old World monkeys, apes, and humans. So these species tend to be both terrestrial and arboreal. Geographically speaking, we find them in both Africa and Asia. And of course, humans are global. And then underneath the Old World monkeys, we've got two subfamilies, the cercopithecus and the colobines. So some examples of the cercopithecus include baboons, macaques, mandrills, geladas, vervet monkeys, guenons, and colobus monkeys. All right, so the Old World monkeys are called the cercopithecus. So that one's probably the most difficult one to pronounce, but I do recommend that you practice pronouncing these words. So the Old World monkeys are called the cercopithecus. Their anatomical features, so they have forward or down directed nostrils. They do not have lateral directed nostrils like the New World monkeys do. Their dental formula, so when you divide the mouth into quadrants, you see in each quadrant there are 2 incisors, 1 canine, 2 premolars, and 3 molars. So there's 1 less premolar than we saw in the platyrrhines. They tend to have higher degrees of sexual dimorphism. So remember, sexual dimorphism is simply the differences in overall body size between males and females. It can also refer to the differences in some physical attributes like the sagittal crest we'll talk about later on in this lecture. Also the sexually dimorphic canines that we'll see in a lot of the baboons. They do have a feature called the bony ear tube. So the bony ear tube is kind of like a straw looking feature. Those of you in lab will have the opportunity to really take a closer look at this, but just know that the bony ear tube is basically like a straw that's leading up to the external auditory medius. They do have a specialized specific molar type called bilophodont molars. So when you break up that word, bi means 2, dont means teeth. So bilophodont molars look really symmetrical to me. I'll show you a picture here in a moment, but they look really symmetrical, almost like you kind of divide them in half. The thorax region, so that's essentially the region that holds all of the vital organs. That's where the thoracic vertebrae are located as well. So they tend to have a fairly narrow thorax, whereas we'll see in the apes and humans, we have a more broad thorax. The cercopithecus, many of them have a tail. But that tail is not prehensile, so it has no grasping ability, essentially. Many of the cercopithecus also have a feature called the ischial callocytes. So that's a fancy way of saying tough sitting pads on the rear. So the ischial callocytes, those are an adaptation to allow for long-term sitting in a very hot climate. So imagine sitting on, the African savanna, sitting on the very hot ground, and also sitting on tree branches as well when they're in the trees. So the ischial callocytes, that's an adaptation for sitting for long periods of time on very hot surfaces. They are the most diverse and successful of the non-human primates. All right, so this picture here just shows you a little bit better example of the ischial callocytes. So when you see that really red-looking red rear end, when you're seeing it in all of them, the males and the females, that's usually the ischial callocytes. When you see it only in the females, that red swelling can also sometimes be a signal that that female is an estrus, or that she's fertile during that time frame. And that the high levels of sexual dimorphism, that tends to be related to competition. So we tend to see high levels of sexual dimorphism in primate groups that practice polygyny, or multi-male, multi-female. So polygyny is one dominant male mating with all the females. And then in groups that live in multi-male, multi-female groups, they tend to practice still polygyny, and it's still the dominant males tend to have increased access to the females. But we tend to see the higher levels of sexual dimorphism in primate groups that tend to have high levels of competition, essentially high levels of competition for access to food, access to resources, and access to mates. All right, those are black and white colobus monkeys there. So you see an example that they have a tail, but you notice that it's not really used for locomotion there. So they have a tail, but it is not prehensile. That's a Dock Langer there. So you're seeing the forward directed nostrils. This is a proboscis monkey. I know, very funny looking. They are mainly folivivores, so they eat mainly vegetation, and they actually have a chambered stomach, just like a cow would. This is a dock langur. So you can see a really good example of the anterior facing orbits and the forward facing nostrils there. This is a mandrill. So mandrills, you see really pronounced canines there. That's a male mandrill. And you also see the colorful, the colors in his face, the blue and the red. So this mandrills tend to have pretty high levels of sexual dimorphism. So the males are drastically larger than the females. And they also tend to live in those polygynous mating structures. So one male, multi-female mating structure. And that's a de Brazza's monkey there. So you see another good example of those forward-facing eyes, orbits. And we've got olive baboons here. All right, so let's one more slide. So we've got a really good comparison right here of the New World versus the Old World monkeys. So overall, the New World monkeys are going to have a smaller body and brain, whereas the Old World monkeys tend to have a larger body and brain. Geographically speaking, we find the New World monkeys in South and Central America. We find the Old World monkeys in Africa and Asia. New World monkeys tend to be mainly arboreal. Now, that doesn't mean they don't occasionally come down to the ground. Of course they do, but it just means that they spend most of their time in the trees. Whereas the Cercopithecus tend to be mainly terrestrial. That doesn't mean they don't occasionally go up in the trees. Of course they do. It just means they tend to spend more of their time on the ground. And then the features, the kind of specialized features, we see the prehensile tail, this tail with the grasping ability in the New Worlds. We see rounded side-directed nostrils in the New Worlds. We see lower levels of sexual dimorphism in the New Worlds. They also tend to be highly social, and they tend to be group-oriented. And then the specialized features we see in the Old World monkeys. We see the ischiocalycytes, that's the tough sitting pads on the rear. We see nostrils that face downward. We tend to see higher levels of sexual dimorphism. So that means higher levels of competition for access to food, resources, and mates. And they, just like the New Worlds, are highly social, group-oriented, but they tend to have more complex reproductive strategies. And we will actually go into reproduction in detail next week when we talk about primate behavior and dominance hierarchies. All right, any questions at all about the strepsirrhines, the tarsiers, the platyrrhines, or the cercopithecus? Anything we've covered so far? Okay, so let's do some breakout room work. All right, I'm going to go ahead and stop the recording so that you guys can feel